I have one more experiment to make us understand about the centripetal force a bit better. The main aim over here is to observe the direction of motion of a point on an object having a circular motion. How is that we are doing it? We will rotate a disk. So this is the disk, we'll rotate it. We'll drop a ball bearing on the disk. So this rotating disk will just drop a ball bearing, and we will note the direction of motion of a ball bearing after it gets hit by the disk's arm. So this will make us understand about this, and this in turn will make us understand about the centripetal force. Okay, so let's have the video and then we'll discuss. Then it will make sense. Please have a look at this video. So what happened? I had two ball bearing, right? Two different cases. One got hit over here, another got hit over here. So what happened? See, if I take this as a center, which it is, we can draw an imaginary circle at this point, right? This being the radius, the distance from the center to that point, point A. So OA is our radius, draw an imaginary circle. So if I draw a tangent at point A, what happens? We have, okay, not a good one. Let me do this. We have something like this. So we have a object. Can you see that? It's taking a tangential path. Again, this is something that I didn't make up. You can clearly see. Okay, actually cannot clearly see, but yes, that's the ball bearing. And you can clearly make out it's taking a tangential path to a circle with radius OA. Similarly, if I take somewhere here is your center, this I have not done a good job of drawing the circle, but yeah, I think something like that. With this as the radius, if I draw a circle at that point, say P, if I happen to draw a tangent, again we can see that this particular object over here is taking a tangential path, right? So again, what is that we can observe? Every point on the disk, if released, it will take a tangential path. Okay, so let's make our observation and our conclusion. So what is that we observed? The ball takes a dash path after hitting the disk, tangential path. So what can you conclude from this? The direction of velocity is always tangential to the path of the object. So the same thing is observed. So this ball bearing, when it gets hit, there's a force for a fraction of a second. After that, there's no further force, and there's nothing holding it in a circular path, so it will move in a straight line. That's what your first law of motion tells, inertia. Is it not? So again, you can see that the first chapter is in link to this. It's a continuation. So please don't miss learning any topic. It has to be learned sequentially, the entire 9th grade syllabus, or whatever grade you guys are studying in. All of this syllabus has to be learned in a sequential manner. Okay, so let's look at the definition. A centripetal force is a force that makes a body move in a circular path, right? We need a force to keep an object moving in a circular path, right? And now we are ready to answer a few things. How is gravity related to centripetal force? You know, you're learning about centripetal force, but how is gravity related to all of this? Whatever we learned till now, how is it related to gravity? See, if I take this as our sun, say somewhere over here is our Earth. How is the Earth moving around the sun? Well, around the sun, right? So it's moving around the sun. But how is that it's moving in a circular manner? We just learned in with two experiments that we need a force, continuous force, for something to move in a circular manner. How is that moon around us is moving in a circular manner? How is this possible? Well, we need a continuous force, that is for sure. That's what the experiments told us. So in this case, the force, the centripetal force to be specific, is provided by gravity. Okay. So your answer is planets, moons, which have near circular path, right? As we have understood, any object moving in a circular path need centripetal force, and the gravitational force is the one providing it. Okay. Planets, moons have near circular path. What is this near circular path and all that? Let's not go to that, but yeah. So things are moving in a circular manner. How is that it's possible? Who is providing the centripetal force? It's provided by gravity, and that's why we're learning centripetal force, and that's how it's linked to gravity. Gravity is what holds the planet in orbit around the sun and what keeps the moon in orbit around Earth. Okay, so this can be expanded to other things. So many other things are moving in a circular path in the universe. All of them have the same reason, and that reason is gravity. Okay, and now to answer this question, what happens to the moon's path of motion if Earth disappears? So Earth is moving, not Earth, sorry, moon is moving in a circular, it takes a circular path because it's been pulled by Earth. Centripetal force is provided by Earth. If Earth disappears, what happens? The centripetal force disappears, and as we seen from two experiments, this will take a tangential path. The moon will start going in a tangential manner. Of course, it will get influenced by other objects out there, starting from sun to other planets and so on and so forth. But yeah, in the simplest manner, this is your answer. Okay. So I have a suggestion for you guys. You can web search, why does the Earth go, not Earth, even the Earth actually, to be frank, moon go around the Earth and not fall into it. See, we have a force which is pulling it towards the Earth. Why is that it's not falling towards the Earth? Think about it. You can web search it. And one more interesting question is, by how much force does the Earth pull the moon with? This is something which we're going to study. This is something that we are not going to study as of now. You guys can research on this. It's a good question, and you'll learn a lot about how the planets were formed and so on and so forth, how stars were formed. All those questions will be answered. So you guys can have a look at this question, web search that. And now you guys have to make a note of, running note of the second experiment, sorry. Again, all of this can be asked as a application based question. Observation and conclusion, it's similar again. If you guys are interested, you can write that. Definition also, we have already written it. This is something which will help you guys understand the concept better, chapter better. So I would request you guys to write this down. And this is left to you guys. If you guys feel like it, you can write it. If not, I'm sure you will not forget this answer. And web search things, it will help you understand the topic better. Okay, that's the main agenda, right? To understand something better.